What is Lady Ada?
Hey everybody, and welcome to Show and Tell. It's me, Lady Ada, with Mr. Lady Ada. We're back. Thank you to Noe Pedro and JP for covering Show and Tell. It's good to have some other hosts once in a while, but now you're stuck with us. So let's check in with people.
You can't miss us unless we're not here.
That's true. It's like the other side of the coin. So we're going to check in with some people from the community, see what they're making, hacking, 3D printing, and soldering. First up, it's Shawn.
Hello, everyone.
Shawn is here showing stuff with things that you do at Digi-Key, because we always have Digi-Key on. So special thanks to Digi-Key, by the way.
Yeah.
Yep, and greetings from rainy New Orleans. It has been storming for the past few days. So one of the things I've been working on is I feel like I'm a little behind. I feel like I'm about a month or two behind because I'm starting to play with the Picos. Yay! And the RP2040 is super cool. I've tinkered with the PIO, and the thing that I've been working on, like it's been taking a week, is to build the whole build system on Windows and also get step through debugging working on VS Code. That's been a lot of fun. Taking up like a week of my time because trying to get it working on Windows. It just works in Linux and Debian and Raspbian, and it's just like awful in Windows. So
yeah, you have to learn CMake. Now you're learning CMake. Congratulations.
Yeah, and CMake is great. I love it. It's just like
really, you're the one. Okay.
Like, okay, it works. So it works well for what it does. Sometimes I don't see the purpose, if that makes sense. And I'm sure somebody will get on and be like, "Well, it's a build system to build the build systems." I'm like, "But really?"
Okay. All right. Don't be like Shawn. Loves CMake. All right,
let's not dump on things.
Okay. All right. So what are you building with these Picos?
So CMake is good, and I'm just doing Blinky for now. But I've got a target over here, and I've got a programmer that this is running Pico probe, and I'm gonna share my screen. Share screen. I can do individual applications. All right. So I've got VS Code going on over here, and I finally installed all the extensions. And what I've learned is that, so you've got your debugger, that's running a firmware called Pico Probe. That's talking to OpenOCD, which is a server running on my computer. That's talking to GDB, which is the debugger. And that's talking to VS Code, which allows me to get this pretty gooey step-by-step thing that allows me to do something like this. So down here, I can click on CMake. CMake should actually allow me to do the CMake part where it builds the make files. Once you get it all set up, it's pretty simple. It's pretty straightforward. And then I go to my debugger, click on debug, and that's going to build and send everything over to my target, which is over here. Once that's done, it starts to load OpenOCD, GDB, all that goodness, and it gets me here. So I have full step through debugging now where I can click through and it goes through each. I can even step into things if I want to see functions on the back end, step out of things. And then we get all the way through here. It prints something to the console, which I'll skip right now, and it blinks. Yay! As I step through the line.
And then you'll blink.
And so as silly as Blink seems, it took me like a week to set this up in Windows. But kudos to Raspberry Pi for their excellent documentation to help me get here.
All right. Well, congratulations. You did the thing so that nobody else has to. For everybody else, get a J-Link, okay? Just it's $20. Just
but $4. It's $4 and like only a week of your time. But $4.
You can't put a price on the experience you have.
I know. Well, congratulations, Shawn. Do write up how you did it. I mean, I do like the VS Code integration, so I'll give you the credit for that. That was pretty sweet. I do like the stepping in.
Shawn, where will this be in the Digi-Key world or in the online world for folks to check out?
I will be making sure it's available on maker.io, as well as there will be a video showing this off and how it's working probably in like the next month when I put everything together and make sure it's all written up in a nice format.
Right on.
Okay.
Okay, well, thanks so much, Shawn. Keep coming by.
Yeah, thank you.
All right, next up, Melissa.
Hello, Melissa.
Hello.
What's going on?
I have a thing here. This is a FunHouse here. And I have it running a little application that I wrote. And right now I have it interfacing with Home Assistant. So I can do stuff like pushing this button here, and it'll actually turn off my room lights.
What?
It worked. That's fast.
That's cool.
Yeah. And I can do stuff like I have the dot stars emulating an RGB bulb. So I can say something like Alexa set FunStar lights to purple.
Did you mean FunHouse light?
Yes.
There you go.
That worked too.
That worked.
So, and then it also shows you the temperature, humidity, and the pressure that it's reading off the sensor on here.
All right, good work. That's a really great job you did integrating with Home Assistant. I'm glad, and that's in CircuitPython, so it's easy to mod, and you get access to all the sensors. And then, yeah, people can tweak it more if they want to have the buttons do different things around their house, or have the screen or LEDs light up based on other events in their house if they're using Home Assistant, right?
And there's a slider here they can use, or the touch pads as well,
Okay,
and
cool.
the PIR sensor.
All right, sweet. Well, I know you're working on a guide. We're going to get that published, and so people with the FunHouse can then use it with Home Assistant as their little hardware friend.
And for folks who haven't jumped into Home Assistant stuff, or folks who have, keep in mind when you build your own stuff, you write the code or you can inspect the code, you know what's going on in your home. And I think that's going to be one of the things. If you care about privacy online, you should also think about like what things can you look at and inspect that you're putting into your home. This is one of them. So check it out. All the code's available, all the projects, you can do all that stuff.
This would be handy for us. We could have, like a near when we're leaving the house, you can like just use one button to turn off all the lights or turn on all the lights, like all of them in the house. We used to have a little clicky thing, but it stopped working for the hue lights. So this might be a good alternative. All right, thank you, Melissa.
Thank you, Melissa.
And
Yeah, you're welcome.
House.
All right, I had heard. I saw this article zoom by, and I want to see what if it's true or not, because it might just be like outrage click. Is there was a company that had a thermometer, IoT thermometer that works with Alexa.
Yeah.
And Amazon said, hey, like we want all the user data because we want that as part of this Alexa ecosystem you're in. And they're like, no, we don't want to do that. And they said, okay, fine, you can't sell it on Amazon anymore. And everyone's outraged because they're like, oh my gosh, like Amazon could stop that? Like, yes, because they're the store and they make something like Alexa. I don't know if this is true. That's why it sounds clicky to me, but I'm going to check it out because that would be another good reason to consider what other devices you add.
You could use a FunHouse.
Yeah, but if you add another device as part of this stuff, maybe you don't want to use another thing that's capturing data unless you know about it.
Yeah.
How you know about it. Anyways, Noe Pedro.
Control your data.
What's going on?
Noe Pedro, what's going on?
Hey, what's up, folks? Let's do a little share screen so we can look at this one. So y'all remember this one? We did this one last year. It's a little 8x8. And I just wanted to look at it, just be like, all right, this is what we did last year. So this year we went from 8x8 and we scale it up to 32x32.
More pixels.
More pixels. These are not NeoPixels, but they're RGB, and it's using the new RP2040 feather, which is back here, and it's on a doubler with the RGB matrix featherwing. So the RGB matrix feathering works with the M4, the M0, and now the RP2040. I got a PR in the works, so it uses the matrix portal library for CircuitPython, so you can do things like animate some sprite sheets, which these are bitmap sprite sheets, and they're just animating and cycling through. Yeah, so we got black LED acrylic. That's the magic here that makes the diffusion look so good on these LEDs. And a 3D printed grid, which squares it up to make it look like little squares. Also got some feet here in the bottom so that it doesn't tip over. And yeah, that's this week's project, and we'll hopefully have the Learn Guide out a little bit later this week.
I love it. It's adorable.
We got a couple of videos we'll be showing tonight on Ask an Engineer.
All right, thanks, folks.
All right, thank you.
Bye.
Pixels. All right, next up, Jepler. I heard you love CMake also.
I mean, it's not my favorite because I'm not good at it, but we were talking about not dumping on stuff just because it's not what you're most familiar with. So I thought it might be worth
saying. You acknowledge that CMake is loved by some.
I think it gets stuff done. Anyway, I needed an easy project. So I had I'll have to read it off because I haven't learned the name. The Neo Key Featherwing 2 with the 2 keys. And I'm like, what can we do with this? And so I came up with the idea of a demake of, it's a game, whack-a-mole. So the light is the mole popping up, and then you have to hit the correct button before it disappears, and then you get red or green. And this is hard to play in the mirror, even though I practice.
Yeah, you're doing pretty good.
That's how it's the advanced level.
But yeah, so it's just, this is actually a Feather M0 because it's what I had, and a little battery and the Trinky with some of the linear switches, the black ones. They pop on and off. It was really easy to put together. A little soldering, a little Python code, all good stuff.
This could be training for like video game people. It's like fast keys.
Yeah, so I mean, you could embellish the code with a lot of things. You can make it speed up because it goes at a pretty leisurely pace. The other idea I had was half Simon. So like, you know, the good old Simon game with the 4 buttons. Why not make one with 2? It'll be easier, right?
Yeah. Or tougher because there's more to memorize. I don't know.
Yeah, you might be able to get more codes or whatever.
All right. Well, thanks for coming by, showing off your Neo-Key. I think we're gonna do some CMake stuff soon. So
yeah. Well, I think there's just plenty of fun things waiting to be done in this package. And so if you have a game demake idea, spend an hour or 2 and see what you can come up with.
Who doesn't love cookies? All right. Thanks, Jepler.
Thank you.
Good night.
Next up,
JP. Welcome back.
Hey, thank you. So let me share a screen real quick. I didn't want to do this before and accidentally share on top of something else. Let me bring up a window. All right. So this is a FunHouse, and I am getting ready to do a little bit of a sort of a home automation thing, but it's going to be a little simpler than what Melissa was showing. This is going to be a real sort of basic thing that people want to do with this type of device, I think, which is I have the PIR sensor loaded there into the front of the board. And if I wave my hand in front of it, you can see it's just changing the neopixels to red, and then it'll pop back to green. So I'm going to use this as the trigger for some Wi-Fi light bulbs. We have both the Philips Hue and we have the Lifx, L-I-F-X brand bulbs, which are straight Wi-Fi bulbs. They don't use a hub or anything. You can talk straight Wi-Fi to them. And we have a library. I haven't touched it, but Brent tells me that it probably should be working now. And I trust Brent, so I think we'll get it working. And I'm going to use this to create a triggered lighting situation where you can maybe just change the color when someone walks into the room or turn the bulb on or off, that sort of thing. So this is going to be something I'll be working on tonight and therefore hopefully have ready for the workshop show tomorrow. And then I'll be doing a learn guide on this pretty soon.
All right. Thank you, JP.
Thank you, JP. And we'll be showing a couple of your videos tonight on Ask an Engineer.
Very fun. Thanks, all.
All right.
All right. Good. We know JP is not a zombie.
All right. Scott, what you got going on?
Hello. Sorry, I'm distracted. I have a cat on my lap. We rearranged in here so he can get up on my lap now without me having to pick him up. So
he's now the new cat home.
He's very happy. So what I've got is I was doing some GitHub stuff. Lamore, you kind of asked me about this, where folks are have some trouble sometimes with CircuitPython libraries because we have all these automated tests and they don't always pass. So you asked me to take a look and see if we could automatically link them to the guide. So what I have here is I actually have two different GitHub actions that I've created. These are things that you can actually use in the workflows that automatically trigger. So they're defined in one place and shared across. So the first one is what I was talking about, where this is like GitHub Inception, because it's a GitHub page with a screenshot of GitHub. But here is my sample PR, and you can see that there's these eyeballs here, and then there's a GitHub Actions bot post that says, hey, thanks for the pull request. Here, take a look at these places for tips, and if you have questions, join the Discord. So that's the first of the two bots, and the eyes are actually done by the bot as well. The bot uses the eyes to actually to know whether it already posted or not.
That's funny.
Yeah, it's kind of a neat hack because I could download all the comments and like compare them to see if it's one from myself. But if you set a reaction, it will either tell you whether it was created or it already existed. So that's super easy. You just create the reaction and it tells you whether it already existed or not and go based on that. So that was really handy. And then as I was digging into all of the stuff that actions can do, I also discovered a thing called a problem matcher, which is a very kind of like weird esoteric thing. But what it does is it allows you to run a regular expression across all your log output. And it will highlight any of the lines that match and potentially pull information out of them as well. So what it means here is in the summary of the GitHub workflow run, now you can see like more details about what failed, which of the pre-commits failed, and then hopefully more information. And then you can also look in the logs, and it highlights the lines more obviously. One thing you had said is like, oh, it says failed, but like it's just a normal color. It's harder to see.
Well, it's because it has a happy cake, and it's like all done, and it's like looks like it succeeded, but actually happy cake means it failed.
Right. So this reformat, or for the problem matcher, is finding any line that says reformatted, and it actually pulls the file name as well. So the last thing is if you look at the file on your like files view of your pull request, it actually will have annotations here that says like, oh, this file was reformatted. And so that'll tell you in the same place that you would do like your normal pull request review stuff. And if it has a line number, like the Pilot stuff will have, it will actually put it on the appropriate line as well. So hopefully people will start seeing that as Dylan helps roll it out, and hopefully it'll be helpful for folks.
All right. Thank you, Scott.
Thank you so much. And if everyone wants to see what it's like to do something like CircuitPython with hundreds of boards, hundreds of libraries, multiple languages, not just programming languages, but like languages for each firmware. Look at all these tools that we're doing with GitHub and GitHub Actions behind the scenes, because that's really what's allowing a lot of this to happen. So check out Friday on Deep Dive with Scott.
Yeah.
All right. Thank you, Scott.
Thank you.
All right. Next up, we got about 12 minutes, and we got about 5 people, about 2-ish minutes each, which is exactly the time budget we do anyways. So let's see how it goes. Let's start with Robotics CoLab. Hello, Robotics CoLab.
You have a robot.
Hey, how's it going? My name is Dan O'Mara. I'm from Robotics CoLab at Circuit Launch, and I've got a little robot here. This is a robot that we built in 12 weeks during our session, and it's an open source robot from Pollen Robotics, and we were the first group to be able to actually build it in FDM and make it. So I'm just going to jump into a quick demo of recording a little wave for you and say, hi, everybody.
Okay.
And then we're going to go ahead, and I'm going to sit back so he doesn't whack me in the face.
Yeah, I know.
I really like the recording the features that you could do with robotics, where you do the movement and then you play it back.
Does it want to do it?
Oh, compliant. All right, there we go.
Okay.
And hello.
Hi. Oh, so cute.
That's Robot Friend.
Robot Friend.
Yeah, so he does all sorts of things from computer vision to, different emotes and just about everything. He's a great learning platform. And so we run a 12-week program here to learn all about robotics. And so Ricci's one of our fun little toys that our students get to play with.
That's a great bot.
Post up in whatever video chat that you can post in the link for more information if for folks can find out about this. You can put it in Discord or YouTube or whatever. And if you want to, next time just email pt@adafruit.com. We'll do a blog post.
Awesome.
So folks know about the program. And congratulations for building. There's a lot of open source robotics. Like there's open source like Dog and there's Cat. But actually building it and then using it is the other thing. So and then turning it into a class. So
indeed. Cool. Well, thanks so much.
Mission achieved. Good work. All right. Next up, we're going to go to Stuart.
Hello.
Hey, Stuart.
Can you hear me?
What you got going on?
Oh, okay. I'll go quick. It's a lot.
You got 2 minutes.
Okay. I saw someone from Nuts and Bolts build this out of a toaster oven. It's a UV chamber. It has 2 UVs at wavelength of 254.7. So it comes, the UV bulbs come with this. It's a timer. But I got rid of that and I added my own electronics to it so I can customize it. I don't know if you can see that, but I have the rotary here. There's a speaker here. There's a bunch of 3D printed material. But here is where I program and I code, because UVC, it's a UVC bulb, so it's kind of dangerous. And I put the code here. And it comes up with proceed. And then I have actually 2 options, which is one is timed. I time for 25 minutes, and the other is power. So once I turn it on, oops. Okay, here we go. That's my rotary switch acting up. But doesn't look like it's. Hold on. Oh, you know what? I'm sorry.
What's it for?
You can put your phone and keys and things like that
Oh,
inside the chamber.
disinfection.
Zap
Okay.
all the bugs.
Okay,
Yeah.
I get it.
Yeah, let me try it again. Put the code in. So 4-digit code.
The door alarm is pretty effective. You just can't use it yet.
Okay, so here it is. So once it starts up, I don't know if you can see the display here.
Yeah.
Yeah.
UV sanitize.
So it has a voice
Use
on it.
extreme caution. UV sanitizing system ready.
So you can go in and punch in a time that you want. So say for instance, I punch in my time.
Alert. UV radiation executing in 10 seconds.
So it gives you 10 seconds of delay. So once 10 seconds kick in, and then it will start the UV. Now inside I have the acrylic here that shows the UV kicking on.
Oh, wow.
Here I have the UV power indicator, the UV sensor because I have your sensor inside the chamber, and the door alarm. If the door opens,
alert, door is open.
it cuts the UV.
Cool.
Close it back, and it goes back if there's any time left on there. So the time feature is the same thing, but it automatically shuts off after the 25 minutes is breached.
Yeah. So, all right, great work.
Outstanding. You made like a commercial level device with I see a lot of Adafruit in there.
Awesome.
Well, I used your UV sensor. I have the Hall effect sensor at the door, and I use 2 microprocessors, one for the timer, and of course one for all the other functions, and of course a bunch of your other stuff.
All right, excellent work, Stuart.
That's great engineering. I love all the safety features.
Thank you.
All right, stay safe, Stuart.
All right, next up we're going to go to Michael. Hey, Michael, how's it going?
Hi, how are you guys?
Hello.
Hi, so I finally finished the hardware for version 1 of my satellite phone messenger thing.
Oh, right.
I'm going to switch my camera here so you guys can see it
a
little bit better. This has taken me forever to make, and I am planning on making a version 2 that will be completely like open source and all that. And I want to be using like easier components. So that's what version 2 will be. But yeah, version 1, it's software-wise not complete, but hardware-wise it is. The user interface, I actually designed in Photoshop and then exported them as PNGs and then converted that to a bitmap image. So that's how this entire user interface is operating. And if I were outside, I would be able to, I'm going to turn that off and on again. I would actually be able to like text the pre-programmed number I have in there. And this thing is very interesting. So it uses the Rockblock 9603 modem, which is quite fascinating because it uses short burst data. Meaning basically it has to charge up these 2 big capacitors inside there. And if it's able to find a satellite, like it will attempt to send it, which is really interesting. And then server side, it's super complicated. I have it like connected to a thing called like Zapier, which then connects to Twilio. Which
I use that.
It's crazy.
We'll keep at it, and when you do the version 2, come back because it takes time. But you're learning a lot. You only learn when things don't work out. You don't learn when things do work out. So
and
a good process for you.
Yeah, and currently I'm using this keyboard, but I did find this keyboard, which is made by Solar Party, which I know you guys carry their other thing that they have. So this thing is incredible, and it's not that costly at all. And I've never actually used one of these keyboards before, so it's
okay. Well, use it and come by next time and tell us how it went.
Yeah.
All right. Thank you, Michael.
Good work. Satellite phone.
Okay.
Next up.
We got 2 minutes per person. Next up, Sai.
Hi. So a couple of weeks ago, I showed this Pico cellular board. I fixed the problems in the design, and you guys gave me a great idea. You coined the project Pico Phone. So I went on Amazon, got a landline phone for $40, and what I did was I threw one of these boards inside, and I attached a keypad. And what this does is that if you dial a number on this, it would text you a joke. I got it working. So what I did was I used a combination of Twilio and a jokes API to text a joke. And when we ever, if we ever return to a normal world, I plan to take this to a maker fair.
Oh, great!
That sounds great.
Yeah,
We could all use more jokes.
Good
Yeah.
project. Two projects in a row using some of these web tools to glue stuff. Once you have like an API, like the jokes thing might be like a JSON format, and then you can use Twilio, then you can move this thing over here, over here, over here. So that's kind of cool.
Yeah,
Congratulations on getting it working. Yay!
All right, Pico Phone.
Pico Phone.
Good work.
Ding, ding.
Thank you.
If you post anywhere, let me know. You can email me pt@Adafruit, and we'll blog it up and all that.
It's on Hackster, and they actually featured it on their landing
Oh,
page.
cool.
I'll send
Okay,
you
great.
the link.
All right,
Yeah.
good work.
Thank you so much.
All right,
Thank
thanks, Sai.
All right, we're gonna go to Rick and then to Mark. Rick, keep
Hey,
it to
how you doing?
a minute or so, and take it away.
Can you hear me?
Yeah.
Okay. Yeah, I just wanted to show you real quick my first little project I managed to get on GitHub. It started out as a Adafruit 328p feather, and I just put everything on it. And I was just going to stick it on top, but I got one of Noe and Pedro's files and printed a box for it.
Why?
And this is a dog feed alert, is what it is. And see, it blinks. Well, when you feed the dog, it comes out of sleep. It blinks green, and then you close it up, and now it sleeps for 7 hours.
Yeah.
Yeah.
So you know if the dog hasn't been fed, because around here with 4 people, we don't feed the dog all the time.
And also, the dog will lie.
The dog will always say it hasn't been fed.
You can't trust the dog.
Colin made a cat feeder one too. There's a cat reminder. Their cats do the same thing. They lie.
Oh yeah, well my cat just gets fed whatever she asks, so that's our cat.
All
We have one
right.
cat, one dog.
Excellent work.
I got it up on GitHub. I'm not sure where to post it, but
You could just email it to pt@Adafruit.com, and I'll get all these in the blog. I'll probably have Noe and Pedro blog it up since you use.
I'll come up again. I've got a project where I control my duct system in my air conditioner here. I used to be in that business in Florida before I moved back here and retired. So, but I'm not an engineer, but I'm an electronics hobbyist, and I've always been into electronics as well.
These single-serving IoT things are one of the reasons we do what we do, because all you wanted to do is one thing. All you want to do is like, did I feed the dog or not? And you can't really buy that off the shelf. You actually have to know that there's a problem for AC ducts or for leaks. So our big AC systems that we have at Adafruit, they use like a proprietary thing. If there's a leak, it'll beep. But we have our own stuff, which if it leaks, it texts us. And that's what you want it to do.
Well, I put mine in because the duct system in this house, there's 3 zones, but 2 of them are tied together, and one of them is down here in my room.
Yeah.
So now I can control that duct to come on only when I want it to, so it doesn't get too cold or too hot down here. As well as detects what the system's doing. But I'll tell you about that next time I show.
Yeah,
come by next time.
Come on by, and these are the type of projects we like to see, because people they know of a problem they want to solve, they just don't know these things, and so that's where we
exactly. And I've solved a lot of those problems already.
All
Okay,
right,
Rick, problem solver.
Take care.
Thanks, Rick. All right, Mark, play us out.
Play us out.
Sounds good. Of course, the camera turned off. There we go. So it's a work in progress. I decided to make another circuit board, and this one, I've got one together, but if I take the feather off, it's probably not getting back on because the headers aren't quite aligned. And I also learned a valuable lesson about checking your footprints before you go to fab. But I wanted to show it this week because it's been just about a year since I made my first appearance in Show and Tell. And I was right at the start of the pandemic, and I remember it was right around the time that when I started watching, you guys would always send stickers out. And you stopped, and that's fine, and I totally understand why, but suddenly I thought, wait a second, we're makers. I can solve this problem. So I've made my first featherwing,
Yay!
which is an As Seen Show and Tell sticker.
I don't have to send you a sticker now.
Yeah.
I'll send you a sticker for the sticker thing.
So yeah, this is the first board that actually does stuff, and it's the first one I made lots of mistakes on. So I'm still waiting for the second and even third revision to come out. It's a light sensor in the middle. If you cover it, it stops. And the footprint that's wrong in the middle is actually a motion sensor, which will be by far the smallest part I've ever tried to attach. But hopefully when I get the new boards and get them all done up, I'll show up again and show off the whole thing.
First up, thank you for participating over the last year. I know we all needed it. And thanks for showing your projects in progress, and then for a great 1-year anniversary and As Seen on Show and Tell circuit board. So thank you so much.
Yeah, you guys are welcome. This came out way better than I thought.
Oh,
and if you
great.
guys want a copy of it, when I get the final one, I'll send you guys one as well.
yeah, I'll trade you a sticker for it or something.
Sounds
All right,
great.
Thanks, everybody.
All right, thanks.
Have a
Mark.
great night.
All right, everybody. Thanks so much for participating in Show and Tell this week. Come by every single week, 7:30 p.m. Eastern Standard Time. It's usually myself and Lady Ada. But then some weeks, Noe Pedro, some weeks it's JP. Who knows? We've been doing Show and Tell for about 15 years, maybe. It's probably like 12, 11, 13. This is a long time. The longest running only Show and Tell that I know of.
That's right.
On video. And we'll see everybody next week. And in a couple minutes is Ask an Engineer.
Thanks, everybody.
Bye-bye.